Hello everyone. So today we are here to learn about Pythagoras theorem. But before we learn about the theorem itself, let's learn about the person who formulated the theorem. So his name is obvious by now, it's Pythagoras. So please don't mistake this picture as the Statue of Liberty because it's not. This is my best effort at drawing an ancient Greek philosopher. So Pythagoras, he was born in 570 BC. That was like 2,600 years ago. And we like to see him as a mathematician and a scientist, but he was more than that. He was a philosopher and he was an expert in religion. And apparently he also proposed the idea of vegetarianism, which was not a very usual topic back then. So he also proposed ideas on proportions, and he also established the Pythagoreanism, and he died on 490 BC. And that's all about Pythagoras. If you need to know more about it, you can obviously search it on Google. And now that we know a few facts on it, let's dive into the actual theorem. Okay. Pythagoras' theorem only works on right-angled triangles, so it won't work on an acute-angled triangle or an obtuse-angled triangle or any other angle it is. So because of this, we can actually check if a triangle is right-angled by applying Pythagoras' theorem. So first let's draw a right-angled triangle. Let's get familiar with a right-angled triangle first. So like every triangle, a right-angled triangle has three sides, which is obvious. And the speciality is one of its angles will be 90 degrees. It has two medium-sized sides, and the third side, which is the longest side, is called the hypotenuse. Hypotenuse. And the hypotenuse will always be the longest side, and it is also the side which is opposite to the 90-degree angle. And you could call the side which is at the base as base, and the side which is upright as the altitude. A right-angled triangle is one of my favorite triangles because there are a lot of applications in mathematics with this right-angled triangle, like in trigonometry and calculus. So now let's get into the Pythagoras theorem, which is the most basic thing about a right-angled triangle. So Pythagoras theorem says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So I can say that hypotenuse squared is equal to, over here it's base squared plus altitude squared. If I name the sides as A, B, and C, you can say that a square plus b square is equal to c square. So that's it. That's all about Pythagoras theorem. So when you hear the name, you might think it's such a big theorem, but this is the only theorem. And now let's solve a few problems on it to really understand the concept. Find the third side of the triangle. So we have been given a right-angled triangle, and we have been given the two sides of it, and we've been asked to find out the third side. So since this is a right-angled triangle, we can use the Pythagoras theorem, which says that base squared plus altitude squared is equal to hypotenuse squared. So this is the base. So we can plug in the values. It is 4 squared plus altitude is 3. So 3 squared is equal to hypotenuse squared. 4 squared is 16. 3 squared is 9. That is equal to the hypotenuse squared. So we will get hypotenuse, I'm just going to write it as h for convenience, is equal to h squared is equal to 16 plus 9, that is equal to 25. So now we got the squared of the third side, but we need the third side, not its squared. So we'll just take the root of the answer. So root of 25, that is equal to 5. So we got the answer, which satisfies the triangle. So this is it. Now let's do another problem. Here's another question. Let's do it together. So we've been given the base and the hypotenuse. So we are asked to find out the third side, which is the altitude. So just like before, let's write down the formula. Base squared plus, let me choose another color. Base squared plus altitude squared is equal to hypotenuse squared. So we've been given the base as 5, so it's 5 squared plus altitude squared will remain as it is, and hypotenuse is 13, so 13 squared. So altitude square is equal to 13 squared minus 5 squared, that is equal to 13 squared is 169, 5 squared is 25, and we'll get it as 144. So altitude squared is 144, so altitude will be equal to square root of 144. That's equal to 12. So we found the third side. So these are the different ways we can find out each sides using the Pythagoras theorem, whether it be the hypotenuse or the altitude or the base. And the sides doesn't always need to be whole numbers, it could be decimals as well. So the base could be 4.3 or the altitude could be 7.6, and we'll get the hypotenuse once we calculate it. So we'll do another problem like that. So let's do this. The base is given as 4.3, so I'll write 4.3 squared plus altitude is 5.6, so it is 5.6 squared is equal to, the hypotenuse is given as c, so I'll just write it as c squared. So 4.3 squared is 18.49 plus 5.6 squared is 31.36, and that is equal to c squared. So c will be equal to square root of 18.49 plus 31.36. So this will give us approximately, so it's not equal to, c will approximately be 7.06 units. So now I've proved that even decimals can be used in Pythagoras theorem. That's all for now. I hope you understood the concept. And if you liked the video, please like and subscribe. It means a lot to me. So I'll see you in the next video.